good.
Now you-
I won't block the camera.
That's fine. So you've done our ground? Did you go through our
I
ground?
didn't go through ground.
Okay.
I just winged it. But he has passed the test.
You have passed the test?
Yeah.
Okay. So, and you're doing, your
Stage
stage
two.
two?
Yeah.
And you're doing your cross countries now?
I'm about to, well, after you get done with me, yeah.
Okay. So, weather, of course, is a big deal, and I know that Rick really emphasizes that with you. So, I'm not gonna get into how you check weather and all that stuff. All I wanna talk about is what's gonna come up on check ride. So this is more prep for stage 3 and for the check ride.
Excellent.
The questions that get asked, and like in our stage 2 oral guide where we look, so it basically says, tell me about the kind of weather that you can expect with the low pressure system, high pressure system, cold fronts, warm fronts, occluded fronts, right? So let's do it that way. Let me ask the question first and we'll talk about it. So in general, we realize there's exceptions to everything, but in general, what kind of weather can you expect with a low pressure system? So out here, Denver, there's a low pressure system. What kind of weather, if we were flying towards Denver, what kind of weather in general would we expect? Well, look at him, he already knows the answers, you can't use him.
I would expect cloudy weather.
Okay, all right. So generally not better weather, but worse.
Worse, yeah,
Okay,
yeah.
so you're heading towards a weather system.
Right.
Most weather systems are wrapped around lows.
Uh-huh.
So if this was late August and you had a low pressure system out here that was really, really low, what do they call those?
Hurricanes.
You got it. Okay, that's bad weather, right? Okay. So which way does winds flow around a low pressure system?
I don't know.
Okay. Real important that you
Yeah.
know this. So I'm going to give you a
It depends
way.
on which hemisphere you're on, right? Or does it?
All right. Well, we're going to pretend like we never fly in the southern hemisphere
Right.
because we don't have the range to get there. Okay.
Are you recording?
I think so.
Oh, okay.
I hope so.
Checking.
Huh?
Just checking, make sure you turned it on.
I think I did. We'll
All
see. If not, then I'll just do it one-on-one with my student. Okay, so here's how do you remember that. Take your right hand, not your wrong hand. Take your right hand, make a fist. Stick your thumb up. Put your right hand, not your wrong hand, low to the table, okay? Because it's a low pressure system, okay? Now, looking at your fingers and your thumb, tell me about the winds. They are rotating in what direction? Use your fingers. So they're rotating in which direction? Clockwise or counterclockwise?
Counterclockwise.
Counterclockwise.
Yeah.
Are they rotating in or out? So this would be out. See where my fingers are pointing out
Yeah.
away? So are they
In.
In.
Yeah.
So the winds are going in and
up.
up.
Oh,
Okay,
alright.
so you take your right hand, not your wrong hand, put it
Yep.
low to the table,
Uh-huh.
curl your fingers.
Yep.
It shows you that they're rotating counterclockwise,
Counterclockwise.
inward, in
Yep.
towards your chest, right?
Right.
And up.
Okay.
So that's the circulation of a low pressure system.
Okay.
If you thought about the worst of low pressure systems, it wouldn't even be a hurricane, it'd be a tornado,
Right.
right? And you watch those winds go counterclockwise and go up
Right.
and out,
Yep.
this isn't Kansas anymore, Coda, right?
Right, right.
So a low pressure system. So the winds are going counterclockwise
And up.
and up and inward. So they're working their way inward towards the center.
Okay.
Now, these lines around a low pressure system, and I'm not a meteorologist, so I'm keeping this dumbed down because I'm not that smart. These lines are called what? Play with me. What are they?
I was about to say ISO something.
Okay, so isobars.
Okay.
Okay, so the winds are called isobars,
Okay.
and they are lines of equal pressure. Okay, if these isobars are closer together, and out here they're farther apart, what do the isobars tell you about the winds when they're close together?
They're stronger.
Yes.
Yeah.
Okay, I kind of compare it to a topographical map. If you
Right.
look at a topo map where the
It's
lines are close
steeper.
together, that's a cliff.
Yeah.
Right?
Yeah.
Well, there's your pressure cliff.
Ah.
Okay? The greater the pressure gradient,
Right.
the greater the winds are going to be.
Oh, yeah.
Okay? Now, in levels above 3,000 feet above the ground, the winds are circulating parallel to these isobars.
Right.
Okay? So, but wait a minute, I thought they were going in. Well, they are. But where they're going in is closer to the ground. So
Okay.
it feeds at the bottom and works its way up.
Okay.
Okay? And we'll talk about why here in a minute. This becomes important when we're even doing things like making a landing on a long straight in approach, because the winds will shift as you get closer to the ground.
Right.
Okay. We'll come to that in a minute. And if we have to break, we can always break. This is just us. So there's another kind of pressure system called a high pressure system. So I'm going to draw a high pressure system out over Illinois, and winds circulate around high pressure systems. So let's figure out how the winds will go there. Want to try?
Sure.
So take your right hand, not your wrong hand, and show me. Yeah. So you take your right hand, not your wrong hand, you put your fist high above the table.
Right.
Okay?
Yep.
Your fingers are showing the wind direction. What's the wind direction?
Clockwise.
And
Down.
out
And out.
and down. Right? So
Yeah.
if you're going to answer the question, it's clockwise,
Clockwise.
outward,
Out.
and down.
Okay.
Okay? So the winds around this high pressure system are they're basically spiraling out. And where are they going? Where does that air want to go? So we have high pressure. We have a pile of extra air molecules in this spot and kind of a hole of fewer air molecules over here. So
It wants to go to the
it
low
wants to
pressure.
go to the low.
Yeah.
So it feeds the low.
Right.
So high pressure pushes. Low pressure doesn't suck. It just needs to be filled in by high pressure.
Okay.
Okay. Now, let's talk about, so that's just the basic pressure systems. What kind of, in general, if we were flying towards Chicago, what kind of weather should we expect? If we were leaving here and going there?
Better weather.
Better weather. So
Yeah.
we should be flying towards improving weather. Okay, great. Now, fronts, a couple of different kinds of moving fronts, cold fronts and warm fronts,
Mhm.
okay? So the air that is displacing the other air gives the name to the front. So if we have cold air displacing warm air, it's called a cold front, and vice versa.
Yeah.
So cold fronts and warm fronts, what are they attached to? A low pressure system or a high pressure system?
I don't know.
Okay. All fronts rotate around low pressure systems. Okay? So if I have a cold front here, cold fronts in general in the northern hemisphere, assuming in all of the northern hemisphere, but we'll just talk about the US right now. Cold fronts, usually the winds in a cold front are southerly. Behind the cold front, in other words, the push is southeasterly,
Okay.
right?
Okay.
Because this is wrapping around this low, which has a counterclockwise flow.
Right.
Right?
Mhm.
And why is the cold front here and not over here? Why don't you see a cold front like this? Well, usually the air from the south is warmer than the air from the north,
Ah.
right?
Yeah.
Because it's northern hemisphere. So that's why this is a mistake. You won't typically see that. All right. So let's talk about a cold front first. What can you tell me about a cold front that you know from the studies that you did?
Well, they are.
Putting you on the spot. I appreciate it.
The temperature is usually lower than.
Yeah, so the temperature is colder here. Now, when we say cold front, that doesn't necessarily mean refrigerator cold, right?
Yeah.
The temperatures here, I'm going to use Fahrenheit for a moment. The temperatures here could be 70, and the temperature on this side could be 55 or 60.
Right.
It could only be a 10 or 15 or 7 or 8 degree difference between the two.
Yeah.
But there is a difference. What you have is an air mass up here that is taking on the characteristics of the ground that it's been over.
Right.
Okay? So this air mass over here is probably drier,
Yeah.
right?
Yeah.
Colder, denser. The air mass over here may be dry because this is desert area over Arizona.
Yeah.
May be dry but warmer. Okay? So if I have a dry cold front pushing into a dry warm front, what kind of weather could we expect?
dry cold going into the dry warm.
Yeah, it's just two dry air masses, one's colder than the other, the cold is pushing the warm out of the way. But both air masses are dry. Not much.
Yeah.
Because here's the clue. Without moisture, there isn't much weather.
Right.
Okay? All weather systems, so winds are caused by, are a direct result of pressure systems. High pressure systems and low pressure systems are in general, all winds are because of uneven heating of the ground.
Right.
And all weather is because of heat transfer.
Mm-hmm.
All weather is because of heat transfer. Now, there's all kinds of ways to transfer heat in the atmosphere. Some of it has to do with condensation and moisture. I'm not going to get into that too much. But generally, we're pushing down here. Without any moisture in this, not a lot can happen. If there's just a little bit of moisture in this warmer air, you may get some cumulus clouds, right?
Right.
The visibility here might be a little hazy until this blows through. But what's on the backside of almost every cold front in terms of weather, besides cooler temperatures?
Well, snow or.
Not without moisture.
Oh.
Remember, it's dry.
Right.
But in almost every case, behind the front is better weather. Almost every case, right? So remember when we were getting all the rains coming in here a week and a half ago, and we had band after band, and we had rain, and then it would stop, and then rain, and then once that cold front had passed through, what do we have? Bright blue skies, a little windy, a little bumpy, right? Drier, great day for everything but flying, because the flying would get bumpy, and some pilots just don't like bumps, but I'm not going to name any names. So anyway, as we push through here, if it's dry and dry, basically
Nothing.
not a lot, maybe a few fair weather cumulus clouds,
Right.
and change in temperature, change in wind direction.
Right.
That's how you know the fronts happen. Okay. Now, what if this area over here has a lot of moisture in it? So if this low is over here, and now you've got this warm air that has taken on the characteristic of southern Texas and the Gulf of Mexico, so it's going to be saturated with moisture. Now you've got a cold air pushing into that. What's going to be the difference?
I would think that there'd be, some sort of storm, some sort of rain clouds of some sort.
Well, yeah. With the moisture, clouds are going to happen.
Yeah.
So, can you give me a guess as to what type of clouds and what kind of storms?
Thunderstorms.
Yeah. Okay. Do you know why? It's a good answer, but can you explain why, or do you want me to explain it?
No, I need to explain.
All right, very good. All right. So I'll come back to why here in a minute.
Okay.
But while I have my big map up, pretending like I'm the weatherman, let's talk about a warm front for a minute.
Okay.
Okay. So warm fronts are generally to the east side of the low, right? Remember, all fronts are anchored to at least one low.
Okay.
Okay. So the air is pushing around this way, the front is moving forward. So, again, the temperature over here might be 80, and the temperature over here might be only 70.
Right.
But that's still a warm front.
Okay.
Okay? Maybe the temperature is 60 in front of it, or whatever.
Yeah.
Tell me about the kind of weather you would expect with a warm front that you remember from your knowledge test. Do you remember? No? Okay.
Let me think. Hold on.
Yeah, what's the opposite of the unstable, cumulus, and all that stuff?
Yeah. The opposite of unstable. You got stable.
We didn't talk about stability. He brought it up.
Okay.
But
all right.
Forget stability a
all right,
moment.
So you all have good. What's that?
Forget stability a minute. Go ahead. You were doing fine.
So you all have good visibility, right?
No, not so much.
Yeah.
So here's where people get caught up on the stage check. Okay, so we now know that the fronts move around,
Yeah.
right, like this. Okay, and the cold fronts are generally faster or slower than the warm front.
It's generally slower.
You would think so, because when we think of cold molasses and stuff.
Right,
No,
right.
cold fronts are fast.
Okay.
They're like a snow plow.
Okay.
And so I'm going to show you how it works. Let me take this off for a minute. I'll do a little cross section. there's the ground. Let's do a cold front. Cold front, we're going to have cold air trying to displace warm air. So the cold air is going this way, and we have warm air out here. Cold air is generally drier, not always, but generally drier, and denser than warm air. Cold air is more compressed, right? It's generally, and remember, this front is being fed by a high pressure system somewhere, so
Right.
it's pushing that air, okay? Because it is cold and dense, it tends to hug the ground. In fact, it hugs it so well that if it's a fast-moving cold front, there's actually friction along the boundary right here, and so where it should be straight down, it kind of drags a little bit, okay? The faster it moves, the farther back this is, okay? Now, the warm air in front of it, here's the top of the atmosphere here, the warm air in front of it is being displaced, it's being pushed back, but in addition to being pushed back, what's the other direction it's being pushed by the snowplow?
Like up?
Up, right, so it's going up. It has no choice but to kind of be pushed up, it's got to make room for it,
Right.
right? And it's probably backing up a bit too. Now, when it's doing that, if this air, this warm air is stable, if it is stable, we'll get cumulus clouds, okay? We'll get even showery rain, but we won't get what? If it's stable, we won't get
Thunder.
thunderstorms,
Yeah.
typically, okay? We'll still get cumulus clouds, we'll still get uplift, right? But it just won't grow into the monsters of the Midway because it's stable. So when we talk about stability, and Rick mentioned unstable, what are we talking about? How do we know whether an atmosphere is stable or unstable besides hearing it from the weatherman or the briefer?
Good question.
If we looked at winds aloft, okay, what does the winds aloft, not the chart, but the text, what information does that give you on a winds aloft chart?
It tells you the direction of the wind,
And
it tells you the velocity,
and
it tells you the temperature.
yeah, okay. So temperature is key for stability. So you know what a lapse rate is? When we talk about a lapse
yeah.
rate, what are we referring to? Okay, so lapse rate is the amount of temperature that is lost as you gain altitude.
That's right. Okay.
Right?
Yeah.
So what's the normal lapse rate? Do you remember?
Not really.
It's 2 degrees centigrade, okay? Celsius, I guess I'm supposed to say, I'm old. Okay, 2 degrees Celsius per 1,000 feet, approximately. Okay, 2 degrees per 1,000 feet. So when you look at winds aloft, how far apart are the different altitudes of the winds? Well, what are the levels that they do those on?
3,000, 6,000.
Yeah, so they're 3,000 feet apart.
Yeah.
So between 3,000 feet and 6,000 feet, how many degrees should be the temperature drop between 3,000 and 6,000 if you have a normal lapse rate? 6 degrees. So if you have it at 6 degrees or less, 5 degrees or 4 degrees, you have stable atmosphere. Okay? It's a normal lapse rate.
Right.
But what if you go from 3,000 to 6,000 and there's a 10-degree drop? Or 12-degree
then it's
drop?
unstable.
Then it's unstable. So it's the temperature, it's the gradient of the temperature that determines whether the atmosphere is stable or not.
Right.
And here's where we're going to get into a little bit of extra detail on this. This is good for me because I want to be able to teach this better. Okay. If the air is stable, whenever, in order to have a thunderstorm, you need to have two things. You need to have lift and you need to have moisture. Well, it's moist air, we've got lift. But in order to have thunderstorms, we also need to have unstable air.
Right.
And here's what happens. So as the air goes up, it starts to cool. When it cools down to 100% saturation, so whatever the dew point temperature spread is, at some point, clouds will start to form. Now here's what's cool about this, and I didn't realize this until probably a year ago. I was doing a little studying, is that when a cloud forms, we're condensing vapor into visible moisture. So there's a condensation. when something condenses, does it generate heat or is it dissipate heat?
It is dissipating heat.
Generates heat.
Condenses?
When it condenses, because think about this, when something evaporates, is it colder or warmer when something evaporates?
When something evaporates, it's colder.
Right.
Yeah.
So if it unevaporates,
Oh, it condenses. Yeah, okay. So
then
you
it
do the
generates
opposite.
heat. It's actually exothermic.
Right, okay.
It generates heat in and of itself. Now it's not, it's not enough to light a fire,
Yeah,
but
that makes
but
sense.
it does generate some heat as those molecules of water vapor start to condense into visible moisture.
Okay.
It is that generation of heat in an unstable atmosphere where the lapse rate is really freaking huge that causes the cloud to explode into growth, because it's generating its own heat, which is still keeping the cloud warmer than the atmosphere around it,
Mhm.
which then sucks in more moisture, which then makes more water droplets, which generates more heat, and it becomes this feedback loop of growing. And so in unstable atmosphere, the clouds just keep growing and growing, and it's sucking more moisture into this thing, and there's all this updrafts going on in here. And the updrafts are partly because this is pushing forward and moving that's what started it, but now it's generating its own updrafts because of the heating effect of condensing water vapor. And as it goes up, when it gets to a certain point, you have updrafts followed by downdrafts because the water droplets get so big that the updrafts can't keep them in the air anymore, and you get this updrafts and downdrafts, and that causes static electricity, and that buildup of static electricity is where the lightning
Okay.
comes from. Make sense?
Yes.
Okay. That's really more information than we as pilots need, but I want you to understand the process.
Right.
So
Yeah.
if you see on your iPad, on my iPad, if we have unstable atmosphere and it jumps a lot, it actually says right across there, possible unstable atmosphere, when it sees like a 5-degree jump at 3,000 feet. It's kind of warning me, be on the lookout for the monsters.
Right.
Okay?
What app is this?
ForeFlight.
Oh, okay.
ForeFlight. We both use it.
Okay.
And it's a great way to just kind of look at it. Right now, the atmosphere is relatively stable, or at least it was yesterday. I didn't look at it today, because it was just in the past.
Yeah.
Okay, so as it grows up, and then once rain starts falling out of the bottom and the lightning and all that stuff is going, we have a mature thunderstorm. Okay? The more unstable, the faster this moves, the worse these get. You'll notice where I drew it. I didn't draw it back in the cold air, did I?
No.
I drew it out in front of the front.
Right.
Okay? These thunderstorms, this line of thunderstorms, can be 30 to up to a couple hundred miles or more in advance of the change of temperature on the ground.
Okay.
Because as it's pushing forward, like a bow wave in front of a ship,
Yeah.
the wave is out in front of the ship
Right.
a little bit. It's
Okay.
pushing it forward. Does
Okay.
that make sense?
Yeah.
Okay. So, unstable air, we get this. If it was stable air, what we will get is just some puffy little cumulus clouds. Okay?
Mhm.
And out in front of that, there's no lift, so there's no puffy cumulus, whatever you got out here. You could have some haze or whatever.
Right.
All right? On the back side of this, once this has kind of gone through, even if you had the thunderstorms, by the time the temperatures turn cold on the ground,
That's
sunny skies,
done, right?
sunny days are here again. So that's cold fronts. Fast moving, if it's displacing warm, moist air, it's going to cause some weather. These cumulus clouds, if there's enough moisture in the air, could give you some rain, some showery rain, but not necessarily thunderstorms. Cool?
Yeah.
All right. So if we look at, so I'm going to come back to our map in a minute. So now I'm going to do the opposite. So we have a warm front. Air's moving this way. This is a warm front. So this is north, this is south. And the warm air is pushing in, and the cold air is denser than the warm air. Okay? So this is cold, cooler. I hate using cold. Let's call this cooler.
Cooler, yeah.
Cooler, all right? It's all relative.
Yeah.
Okay? And here's your warm air. Now the warm air is lighter, fluffier, one of my students called it, less dense. So it's not as, the retreating air is the cooler air, and it's retreating in the face of the push from the warmer air, but the warmer air has a harder time pushing it. So it'd be like the three of us trying to push a pickup truck. We're not gonna go real fast.
Mhm.
If the pickup truck is pushing us, that's the cold front, right? They can go as fast as it wants. So in here, what's happening is this less dense air is kind of sliding uphill over the cooler air as it slowly displaces the cooler air. So one of the things interesting about this compared to the cold front I just drew is that the interface between the cooler air here and the warmer air here is bigger. The surface where the two are touching each other
Mhm.
is over a big, big area. Huge. Multiple states, okay? Not just a line of clouds, but now this thing could be huge. Okay, so let's first talk about what's happening underneath. Right now we're going to talk about stable. We're not going to go to instability yet. Let's talk about this cool air. What kind of conditions could we expect in advance of the temperature change at the surface? So we're over here. We have cooler air underneath and warmer air on top. There's a name for that. What do we call that?
It's an inversion.
It is. So whenever you have a temperature inversion, what do pilots expect?
Fog.
No?
No?
You're going to a moisture thing.
Oh, okay.
We are talking about something that's similar to fog, and that would be, what is the one thing that we're concerned about with fog?
Clouds.
Well,
Well,
reduced visibility.
Visibility, yeah.
Right.
Yeah.
So underneath here, we could have some reduced visibility because of the inversion. Can you tell me why, under an inversion, the visibility with no moisture whatsoever, this could be perfectly dry, why is it that we could have reduced visibility underneath that overlying area of warm?
You probably have some sort of wind down there blowing up dust.
No?
No.
You could, but
No.
here's,
Stuff gets trapped in there.
yeah.
Yeah.
So it's kind of like putting a lid on the kettle,
Right.
okay? So remember that anything that starts to go up, lift up, like smoke from a chimney,
Mhm.
okay, or exhaust
Well,
fumes,
Right.
will go up until it gets to a temperature that's warmer than it, and then it's gonna
Then it's
flatten
gonna-
out.
right, okay.
Guess what? It's going up at a normal lapse rate, gets to
Yeah.
here, it's warmer above, so it just flattens out.
Right.
And what this does is it traps underneath here all the crap, the
Yeah.
smog, the fog, the smoke, the whatever you got,
Uh-huh.
okay? So the visibility is pretty bad down here. The other thing about that atmosphere, almost under an inversion almost every time, it is typically very stable, okay?
Right.
In fact, that's the whole definition of it, is when the temperature starts to go up instead of down, we have like enforced stability here. So what else can we expect besides crappy visibility if we're flying in advance of the warm front?
Well.
Think about Rick. What would make him happy?
Basically.
Stable air.
Stable air. Yeah.
A smooth
Yeah.
ride, right? So out here, we may not have great visibility. We might be down to marginal VFR. We could have
Right.
5 miles or less of visibility.
Yeah.
But
Smooth.
it'll be airliner smooth, right? Okay. So we'll have that. Now, let's put some moisture in the equation. Okay? Again, we're going to keep it stable for a moment. If we put some moisture in here where the warm air and the cold air are touching each other, especially if there's moisture within the warm air, you're going to start getting clouds. And the clouds will be lower here. They'll be higher because it's about the interface between the two. And those clouds are going to all, in stable conditions, have a certain form. What kind of clouds are those in stable conditions? They're not cumulus.
Cirrus?
They're way up. They're
Yes,
way up
okay.
at 40,000 feet.
All
They're
right.
made out of ice crystals. So we're talking low stuff.
Not cumulus.
Stratus. What's
Stratus.
the- yeah, the
Yeah.
low ones over here.
Stratus.
Stratus. Yeah.
So stratiform, okay?
Okay.
Right, so if you think of like stratus layers in rock,
Yeah.
they're this wide, right? So stratus
So-
clouds.
Okay.
What kind of rain would we get out of those if there was enough moisture in them to give you rain? We don't always get rain out of these, but if we do, what kind of rain?
Think
It's
about
not-
the rain. Think about the rain that when you've got these low clouds all overhead, rains all day.
Yeah, showery, right? Or
No, that's
is
called.
that- no.
That's,
Steady.
Steady,
Steady.
okay.
Steady rain.
Okay.
So if you have a weather system where it's just those low gray days, we get them in the winter sometime where it's just
Yeah.
low and gray and it just stays nasty for 3 days.
Yeah.
But there's no thunderstorms, there's no big turbulence. It just kind of rains and drizzles and drizzles and rains and rains and rains.
Uh-huh.
Okay? Steady rain.
Right,
Okay? So the rain here, you know, as you get out here, and then at some point it won't bother to rain much at all, okay? As this pushes through, but on the back side, what are we going to have?
We're gonna have warmer. Warmer.
And what kind of clouds are we going to have on the back side of this out here?
We may not have any.
May not have any.
Yeah.
Right? Because there's no interaction there. I mean, you could have a few little cumulus or something if there's some thermals picking the moist air up to a
Yeah.
height where you get some fair weather cumulus. But
Yeah.
generally fair weather on the backside of
Yeah.
the front. Okay. So, slower moving, stable and stable. The cold air is almost always stable, but not always. Okay. You have a temperature inversion, so crappy visibility, stratiform clouds, steady rain. Now, watch what happens if the warm, moist air isn't stable. It has a lapse rate that's going up at 9 degrees per thousand. It's going up 3 degrees per thousand.
Mhm.
Okay, 9 degrees per 3,000 foot on the report. Okay. So we're still going to have some stratiform clouds, especially on the cool side of the front in the atmosphere, on the cool side of the slope. But we've got lifting action, we have moist air, and we have instability. What's it going to give us?
Thunder.
Every doggone time, as soon as it starts to make clouds over here, it's self-feeding, and you'll get your thunderstorms. Okay? But, and here's what scares IFR pilots, and we've been doing IFR stuff, Rick and I, a lot, is guess where those thunderstorms are going to be? They're going to be called embedded thunderstorms. They are embedded in the stratiform clouds. So if Rick and I are on an instrument flight and we're in the soup and we're flying through the clouds, everything's fine and smooth here, and then all of a sudden it's like a bully's trying to pull the wings off a fly because we've flown into the base of a towering cumulus cloud we couldn't see. So when it's unstable, it's more of a danger for people flying in clouds.
Yeah.
You know, what's a VFR pilot going to do? Stay home and watch TV.
Yeah.
Okay. So
you can't, if it's embedded, I mean, does it show up on the weather maps or? I mean,
the weather reports will give it.
Yeah.
They'll tell you, and they know about them. And again, they know that the potential is there because when you read the weather reports, it's going to talk about.
It's going to tell you that it's a warm front.
Right. So when you look at your area forecasts and your prognosis and so forth, look at your prog charts. It's going to point that out.
Yeah.
Those weather guys, they're smarter than us, so they warn us. They don't fly in it either. So they don't fly. So there's your warm front, right?
Yep.
So stability isn't, and this is something to keep in mind when we start talking to our students, is that they kind of get hit with the stability thing as almost a dominant thing when they talk about warm fronts and cold fronts. And stability can either be or not be depending upon the lapse rate.
Right,
So,
yeah.
Fronts and stability, and one of your students that you and I both know got really hung up on that. And so what we have to do is to de-emphasize the stability or explain when stability is applicable. Okay? So if it's stable, we're going to get stratiform, steady rain, lots of clouds, but smooth, and poor visibility underneath.
Yeah.
If there's instability on the warm side, you're also going to have some thunderstorms.
Right. Okay.
Does that make sense?
Yep.
Now, let's go back to the map depiction. And here's when a pilot is planning his cross country. This gets to be important. Use a black. Okay. So we're headed across the country, and here's this low in here. And we have I'm going to do this in black and white because that's how the charts are, right? Unless you have an iPad. Okay. And we have a warm front. Now, warm fronts have the
Half suns.
half suns. I think of them as bubbling right? So boiling water, okay, and icicles, right? That's
Yeah.
how I keep them straight. So let's talk about cold fronts first. They're easier. So we already know that that fast-moving snowplow is going to give us either cumulus and showers, or if this area here is unstable, what's it going to give us?
Towering cumulus.
Yep. And thunderstorms, right? And again, they're going to be in front of that front. Imagine that. Okay. So we have a line,
They call that the squall line, right?
squall line, a line of thunderstorms. Okay. This is where angels fear to tread. Nobody wants to go there.
Yeah.
Airline, depending on how tall those get, airliners will kind of circumvent some of
Right.
that. Okay. And these monsters can be huge. And what do pilots do? We just stay on the ground and wait for it to go away and fly behind it. Now, if we were going to go to Chicago, we would route our way around the backside of it, because what are we going to have on the backside of it?
Good.
Yeah, fair weather. Might be some cumulus, could be bumpy, could be windy, but none of this.
Yeah.
Right?
Yeah, I don't want to fly through that.
Okay, but here's the other problem we've got on this particular depiction. Remember that the interface, so this line here represents where the temperature, when you're looking at a current map, it's representing where the temperature is changing on the ground. So remember, that cold front looks like this over the ground. So if they were drawing this on the map, it would look like this. See what I mean?
Right.
So that's how that's being drawn. So there's that, you can just almost see that cold air coming down.
Right, okay.
Now, on the warm front, you have the warm front going this way, and where the temperature changes on the ground, you're seeing your half suns, right?
Yep.
So out ahead of it is where all the weather is. So on both fronts, the impact of the front is ahead of it. Okay? Usually when the front passes, things start to get better.
Right.
And cold front pretty quickly.
The
So
clouds are on the warm side.
they're on the warm side. So remember, this is the warm. This is the clouds are on the cold side of the front. So remember, it's clearing back here. This is moving this way, right?
Yeah.
And the bottom of the front, the bottom of the warm front is right here. So this is the warm air. So this is warm, right?
Yeah.
So
But see
all
that-
those stratus clouds are
they're on-
ahead.
Yeah, they're on the warm side, but the warm goes way far out. That's
The warm goes way far out, but when you look at the map, you look at the cold side of the line of the half suns. Okay? So the weather is on this side of it. And
Yeah.
you'll notice that this is relatively small area, surface area, and this sucker can be huge,
Okay.
huge. So, smooth air, bad visibility underneath, okay? Steady rain, and behind it, it's clearing out. Cool? So if we're headed to Chicago, we can circumvent this, but then we might get into some visibility issues. Now, these clouds will be higher the farther away from the front you are because of the upslope of the warm air. Make sense? So as you get out here, these clouds get higher and higher. So if these clouds are at 13,000 feet, and you're down here at 7,000, even though you've got a gray ceiling over your head,
Yeah.
life is good.
Yeah.
Go to Chicago,
Yeah.
right? Or wait for the front to pass. Now, if you were on your way to Washington Dulles, let's say, then what you'd want to do is you'd probably just stay away from this and go on the back side of that. So stay far in advance of that so you don't
Yeah.
have any problem here.
Yeah.
Now, I'm drawing one weather system here. There's usually more than one over the continent at a time, so you have to look at all of it. Okay, and remember, the isobars are like this around that low. What's feeding this? There might be a high over here, and that air is pushing that cold front.
Right.
Because it's the high that feeds it. Okay.
Yeah.
And there could be a high. There could be a high over here, and it could be feeding it, right? Like this. Air's moving away off the high to try and feed it, because it's all trying to circle the drain. There's the drain.
Yeah.
Okay.
Yeah.
Makes sense?
Yep.
Okay. Couple more we got to cover real quick, and then I'm going to move on to something else. So warm fronts, cold fronts, pretty basic.
Yeah.
All right. What happens though when fast catches up with slow? So, we'll go back to color. Have a low pressure system. And now, since the cold front was faster and it's always wrapping around, and the warm front's slower, so I got a warm front doing this. And the cold front that was here has wrapped around faster. Sometimes they move a lot faster than the warm fronts. And the cold front caught up, so it was like it was here, right? And 12 hours later, it's caught up and overrun. So now we have what the weatherman draws like this.
Sounds like bad news to me.
You think? Can you say all of the above?
Yeah.
Okay? Because now, see this? Here's the cold front, there's the warm front, the cold front catches up, and now this cold front is now here, overrunning the whole doggone thing.
Yeah.
So, towering cumulus, embedded thunderstorms, severe weather, this is a place we want to avoid
Right.
a lot.
Yeah.
Okay? And so it's drawn that way. So what you actually have here is, I'm going to label this cold, warm, cool. So we have three different air masses with three different, where do air masses get their characteristics from?
The weather that the area that they were over.
Right, so they're bringing with it what they were over. So
Right.
if they came up over the Gulf, they're moist and warm.
Yeah.
If they come down from the Arctic, they may be
Cold and
cold
dry.
and dry. If they're over the desert, they could be warm and dry.
Right.
So air masses take on the characteristics of the land that they've been sitting over. Okay, so cold, cool, warm, all of this is coming together. Depending upon stability, it could be just really, really wet or really wet and wild.
Right.
Okay, now, one more, not that it really bothers us as pilots, but I'll just put it in there because it could come up. I will tell you, Dave won't go into this much detail, he's not gonna go this
Dave
far.
is
The examiner.
Oh, okay.
So when you go for your check ride,
Yeah.
so this is like check ride prep.
Right,
okay?
okay.
You will see occasionally on a weather chart, you'll go, what the heck is that? And they'll usually label it in a little box next to it on like a prod chart, and it'll be STN, and it's for stationary, STN1, okay? And it'll look like this. So there's your half suns. There's your icicles. Oh crap. So this isn't an occluded front. That other one where it caught up is called an occluded front.
Okay.
You know the word? OCCLU, occluded. So that's that one where the cold overran the warm.
Right, okay.
Okay?
Okay.
But now what have I got here? I've got a cold front that was trying to push the warm out of the way, and I got a warm front trying to displace the cold.
Yep.
And neither one's strong enough to push the other one out of the way, but we still have a front because this is still a boundary between two air masses. All fronts are boundaries between two air masses. So this is called a stationary front. There was one yesterday, I don't know if it's still there, I haven't looked, but there was a stationary front just like this out over here. Guess what they're having? Flooding. It's not moving, but there's still an interface, there's still heat transfer going on,
Yeah.
there's still moisture in the air, and it's just been sitting there and raining on them. So when you see these big ones where the houses start, the banks overflow and the
Yeah.
houses flow down the river,
Yeah, that's a station.
you can about bet there's a stationary front somewhere nearby.
Right.
Okay?
Yeah.
Unless a hurricane went through or something, but
Yeah,
obviously
yeah.
there's more dynamic weather than that. Stationary fronts can linger for a very long time and dump an awful lot of rain onto the terrain below. But, it's not a big deal to us. Obviously, if we're VFR pilots, we're just not going to go flying that
Yeah,
day
yeah.
again, at least not in that area.
Yeah.
But it is something that can come up in a conversation with the examiner.
Right.
So what the examiner will ask you is, well, tell me about the weather associated with low pressure system. Okay, tell me about, and he might just say, well, tell me about low pressure systems. That's if he just wants to see if you've memorized what we just talked about today.
Yeah.
More than likely, in the new era of 2016, how it's done is he's going to say, well, if we were flying from here to here, right, we were flying from here to here, and he's looking at the prog chart, what would you be thinking about? Tell me what you'd be considering. Well, first off, from there to there, I got a low pressure system in the way. I probably want to be checking very carefully what's the moisture. Is it stable? Is there fronts involved? Is it a minor low, or is it really circulating? What are the winds?
Yeah.
Okay, let's check some weather in that area for between here and there. So we'll check the weather over Utah, check the weather
Yeah.
over, Little Rock and so forth, and work our way to where we want to go.
Yeah.
Okay, so they do a lot of it in scenario. In the old days, they would say, tell me about weather around the low pressure system.
Right.
Which way does it circulate? Tell me about weather with a cold front. Tell me about weather with a warm front. Tell me about an occluded front. And finally, a stationary front. Are there any others that are on our stage 2 or stage 3 oral prep? I think that's it.
No, it's just, high lows, warm front, cold front.
Warm front, cold front, and possibly an occluded front. You may get that. Okay. The examiner that we use is very, very good, but he's going to want to know that you have done the prep for your check ride of the weather, and that you have gathered all available information, and that you have made a go, no-go decision for the big cross country to Vegas or wherever you're going based upon that weather. But he may, in the course of the oral exam, look at a chart or draw something like this, and quiz you about it.
Right. Okay.
All right. So there was my prepared remarks for today. Now I want to go into something just a little bit more, this is fun because, quite frankly, I've been confused about this, and since I was getting ready for my big audience here, I looked this up.
The best way to learn is to teach, right?
Absolutely. We've learned so much doing this, we really have. Okay, so I mentioned before that when you have a low pressure system, I changed colors anyway, and we have our isobars going around it, right?
Mm-hmm.
That the winds are parallel to the isobars.
Right.
So that's true. And what is it that makes the winds go? So I have a high pressure over here. Why is it that the winds just don't go straight to the low? Why do they do this whole circle around the drain stuff? What's causing that?
Remember the mysterious and false Coriolis effect?
False?
Yeah, I don't
You heretic.
I don't
Okay.
believe it. Okay.
Yeah, okay. So Coriolis force is what makes the winds bend rather than go straight from a high to a low.
Okay.
Okay? So because of the planet spinning and,
Yeah.
I don't care why it is, it just is.
Yeah.
Okay? If that's what they want to call it, that's what I'll call it.
Yeah.
But it is that force that is causing the winds to circle here. Okay, but we said that in a low pressure system, it really should be spiraling in. Well, it does. It does when it gets close enough to the ground to feel the friction with the ground.
Right.
Okay? If you have really smooth terrain or you're out over the ocean, it has to get pretty low to feel the friction to start vectoring inward. But what happens is the friction with the ground makes the wind divert towards the low, towards the pressure system.
Okay.
So that would be a diversion to which direction, left or right? Always.
Left.
Left,
Yeah.
right? So if you have a wind that's blowing this way at 6,000 feet, as it gets closer to the ground, it's going to divert to the left. I don't even have to know where the low is. I know it's over there somewhere.
Yeah.
So if the wind is going this way, as it gets closer to the ground, it's going to start heading to the left.
Right.
Okay? Good to know. If you're making a straight in approach,
Mhm.
right?
Mhm.
And the wind is right on your nose, you could probably, you're not having to crab at all to go in. You might be prepared for a little bit of crosswind when you get down there. Now, that's a general rule. It's not an absolute,
Yeah.
right? Because there can be all kinds of things that could keep the wind from, it could be dead calm down there.
Yeah.
How many times have we been up flying at 4,500 over Alpine, getting our butts kicked? We drop down here into the basin and it's like a mill pond.
Right.
Okay, so there are other things involved, but in a general sense, as you get closer, the wind will start to spiral in towards the low pressure system. So, there is that. That's one. Keep that in mind. The wind goes lower, it'll divert to its left.
Okay.
Its left, not necessarily yours, because that, right? So it's
Yeah,
gonna-
yeah.
You know what I mean? Okay.
Wherever the low is.
Wherever the low is.
Yeah.
But you don't have to worry about where the low is. All you have to know is if the wind's going this way, as it gets lower, it's gonna bend to its left.
Right.
Right, which is gonna be to your right.
Yeah, yeah.
But it's gonna be a left crosswind, so it's all the same. Now, one other thing, this is for extra credit and just for shits and giggles. If we took off from here, and let's say we had a high and a high, so the air's going around, oh, wrong way, sorry, out and around this way to feed this way, right? And going around this way to feed another low up there somewhere, we don't care. And we wanted to fly a straight line, but we just grabbed a course. Let's say that we figured out that 080 would be a straight line course to Washington Dulles. That's where we want to go.
Mm-hmm.
And the
Ignoring the Coriolis effect on our airplane.
ignoring everything, right? Just that's the ground. We're just going to fly that heading. We said, man, magnetic heading. If there was no winds, if I held this heading, Washington Dulles would come right up under my butt.
Right.
Okay, but we have all this wind. It's actually works out. Let's say that the barometric pressure was 30.00 inches of mercury. It's nice round figures. And it happens to be 30.0 inches of mercury when you get to the East Coast. Guess what? Regardless of the fact that the wind is going to take your ground track, if you hold that heading, so the wind is going this way, right? So if you hold that heading, it's going to blow you off to the left side of the course. Guess what? If you hold that heading,
You get right there.
you'll get right there. That's what made Lucky Lindy so freaking lucky. It shouldn't have happened, but the aviation gods were looking after him.
Huh.
The barometric pressure when he got to Ireland was exactly the same as when he took off from New York. Okay?
Ah.
And so he just kept, all he could do, because he didn't know what the winds were going to be out there,
Yeah,
because
yeah.
they didn't have that kind of weather tracking stuff. So he was hoping that he could get within 40 or 50 miles of where he was going to hit land there.
Yeah.
So he just flew because he flew a great circle route. He just held the heading for 3 minutes, turned 2 degrees, held that heading for 3 minutes, turned whatever it was, 20 minutes, whatever it was. He just kept flying it.
Yeah.
But since it worked out that the barometric pressure was the same where he took off and pretty much where he made landfall over there, he only missed his target by like 4 miles or 5
Wow.
miles. Okay? So
Yeah, over that long of a distance.
over that long of a distance with no satellite, no
Yeah.
anything else to go. So
somehow, that means that all the pressures in between, the
Equal
winds
out.
caused by the pressures equal out, no matter how many of them that there are.
Huh.
is
I've
that
never-
slick?
I've never heard that.
Yeah.
That's
Now,
pretty cool.
there's been some talk, I didn't believe it until I actually saw this in one of the flying magazines, but there had been some talk now that we can do computerized air traffic control at upper levels, talking about in Class A airspace. There was talk about letting them dispatch that kind of a route where it kind of follows the pressure gradients around and ends up where it's going, but because it's computerized, they could have whole swarms of airplanes doing that and keep them all separated. So they give them a route, but they would give them a heading, a place to hit, so a staging place, and hold that heading to GPS accuracy, right? Ground track or heading, and then just let the ground track do whatever, but since everybody's going in the same direction,
They're all gonna be blown the same way.
I don't know if it'll ever happen, but it's kind of a slick idea. So that kind of takes it to the next level. These weather systems are always, if you boil it down to the really, really simple, from a piloting point of view, really what your examiner and your instructor and Golden State we want you to be aware of is how to look at it and make a good decision. If you have a warm front moving around over here, you know which direction a warm front's gonna move. The winds in a warm front generally are moving northwest. Cold fronts are southeast, warm fronts are slower, bigger weather systems, poor visibility.
Yep.
Okay, once you get your IFR ticket, I'm assuming you'll get that at some point, but once you start flying in the clouds, the big concern with a warm front then is getting into icing conditions, because the rain falling from warmer air is liquid, and then it gets to the cold air underneath, and if that cold air is below freezing, you can get super cooled water droplets, and even though you're flying VFR under the clouds, in the rain, it can ice you up. You'd look like Frosty the Snowman in no
And I
time.
heard you need an instrument rating to fly your drone in the clouds.
Is that right? That'd be pretty funny.
I think you need an instrument clearance, because their job is to keep everything in the clouds
I
from
know.
bumping
Yeah,
into
right.
one
Keep them
another.
out of the clouds.
So anyway,
Wow.
I hope that helped.
Yeah, no, yeah,
That was good, man.
yeah, for sure.
So those guys that didn't show up.
Yes.